Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is maximum average pass ratio. The problem description is too big, so let me actually try to explain you the problem using the input. So we are given two inputs in this problem, classes, which is a two-dimensional data or a two-dimensional array, and there is a variable extra students, which is an integer. Now let me explain you first what is this two-dimensional data which is given to us as an input. The name is classes. It is a 2D data in which every data is a list or an array, right? Now every list or an array is representing a particular class. So there is a school or there is a college in which there are multiple classes. So let us say we are given three classes here, right? So let us say C1, the second is C2, and the third is C3. So we are given three classes as an input. In each of the class you can see we have two data, right? The data at index number 0 in every class is representing how many students in that class can pass the exam, and the data at index number 1 represents total number of students in the class. So right now in class C1 you can see we have 2 students, in class C2 we have 5 students, and in class C3 we have 2 students. In class C1 out of the 2, 1 student can pass the exam. In class C2 out of the 5, 3 students can pass the exam, and in class 3 or C3 out of the 2, both students can pass the exam. And now we have another variable called as extra students, and let us say the value is 2. You can see the value here is 2. Basically this extra students is the number of students we have who can study in any class, class C1, C2, C3. They can study in any class and they are guaranteed to pass the exam. So if I add these two students in the class C1, so the class C1 is going to have 4 students and 3 of them will definitely pass the exam. If I add these two students in the class C2, so the class C2 is going to have 7 students and 5 of them are going to pass the exam. And out of the extra students, it is not required that you add all the students in the same class. If you have 2 students, let us say 1 and 2, so you can add 1 student in class C1, 1 student in class C3, any class you want. Our goal is to return the maximum possible average passing ratio after assigning the extra students. Basically, we have to maximize the average passing ratio, and that too after assigning the extra students. So let us talk about, before we assign any extra students, how can we calculate the possible average pass ratio. Basically when we say pass ratio, we want to find out in what ratio are the students passing the class in every class, and then we can take the average of this, because we have to find the average pass ratio, right? For example, in the current case, if we do not assign any extra students, in the class C1 the passing ratio is 0.5, that is 1 divided by 2. We have 2 students, one of them can pass, so the passing ratio is 0.5. In the class C2 the passing ratio is going to be 0.6, 3 divided by 5, and in the class 3 the passing ratio is going to be 1.0, right? Because all the students can pass the exam. The value of a ratio cannot be more than 1. It is basically the number of students who can pass the exam divided by the total number of students. Now these are the passing ratio of different classes. If we want to take the average of this, we can just add all these data. This will be equal to 2.1 and divide it by 3, because we have 3 number of classes, right? So divide it by 3. This will be equal to 0.7. So as of now we have 0.7 as the passing ratio, but we have extra students as well, right? Now we can assign these two extra students in any of the class to increase the passing ratio. The reason is all these students are brilliant and they will definitely pass the exam as per the question. So if we add these students in any of the class, the passing ratio is definitely going to increase, and if the passing ratio of a class increases, the average is going to increase, right? So we just need to assign them in such a way that the average passing ratio, which is possible, maximizes. For example, what we can do is we can assign these two students in the class number 1. If we assign these two students in the class 1, then the class 1 is going to have 4 students in total. 3 of them is going to pass the exam, and the passing ratio will be 0.75. If it is 0.75, this value will become 2.35, and the average will be equal to 0.78333. So this is the maximum ratio which is possible, and we can return the answer with an error of 10 to the power minus 5. It means we can return till 5 decimal places. Let me reset the value of classes, and let me tell you that our whole problem is about assigning the extra students in the correct classes so that we can maximize the gain. What is the gain I am talking about? I am talking about the current passing ratio. Here the passing ratio was 0.5. If we add these two students in the same class C1, then the passing ratio is 0.75. So we are able to gain a passing ratio of 0.25, right? But if I add these two students in the class C3, so the class C3 will have 4 students. All the 4 will pass now, but still the passing ratio is 1.0, right? It is not going to increase. Our whole goal will be to increase the passing ratio, and if the passing ratio is going to increase, the average passing ratio will automatically increase, right? So that is the whole point. Now let me tell you a very simple strategy what you can follow. What we can do is initially we can try to see that if we add one student in every class, how much gain can we have. For example, if I add one student in the class C1, it will be 2 passing out of the 3. If I add one student in the class C2, it will be 4 passing out of 6. And if we add a student in the class C3, it will be 3 passing out of the 3. Now what is the new passing ratio? We have 0.67. For the class C2 we have 0.67, and for the class C3 we have 1.0. Now you will understand that if you add one student in the class C1, you are getting a gain of 0.17, because earlier it was 0.5 and now it is 0.67. In the class C2 you will see that it is 0.6, now it is 0.67. So the gain is 0.07, and in the class C3 the gain is 0. So the maximum gain we can get is from the class C1. This is telling me that if I have an extra student, I am going to add this in class C1. This is going to give me the best possible answer. Now we can do the same thing with every student. We have two students, right? We have two extra students. For the first student, I can definitely assign it in the class C1 because that is giving me the maximum gain. Now 0.67 is the new ratio after you assign the first extra student to class C1. So this will be 0.67. Let me reset the value of other classes where we are not assigning our value. It will be 3.5 and it will be 2.2. Now again we have to do the same thing. We have to find that if I add one extra student in any of the class, which of this class is going to give me the best possible gain. It is simple, guys. If I add one student in the class C1, this will be 3, this will be 4. So the value will be 0.75, the new passing ratio. If I add the second extra student in the class C2, this will be 4, this will be 6, and the value will be 0.67, the passing ratio. In the class C3 there is no use because after you assign one more student, it is going to be 1.0, no gain, right? Now you will see that in the class C2 you are getting a gain of 0.7. In the class C1 you are getting a gain of 0.8. So you are going to assign it in the class C1. So the next second student is also going to be in the class C1. So now the class C1 is going to have 3 passing students out of 4. The class C2 will still have 3 and 5, and the class C3 will have 2 and 2. And now the new passing ratio of class C1 is 0.75. Now let us say there were 3 extra students. Now where are you going to assign the third students? Again we have to do the same thing. If I assign a new student in the class C1, this will have 4 students passing out of 5. So the ratio is going to be 0.8 and the gain is 0.05. If I do it in class C2, this is going to be 0.67 because now 4 are passing out of 6. If we add the third extra student in the class C3, it is just going to be 1.0. The passing ratio is not going to change. So now you will see that 0.67 from 0.6, which is a gain of 0.07. This gain is more than the gain you will get if you assign third students in the class C1. So this time you will assign the student in the class C2. So that is going to be our whole logic. We are just going to see which next class is going to give me the best possible answer, and every time you find a new answer, you will update the number of students in that particular class. But we are not going to loop through our whole data every time. That is, for every student we are not going to make a loop in the whole class. What we can do is we can actually make use of the heap data structure. And this will be the max heap. That is, every time you fetch the next value in your heap, that is going to be the maximum possible. And how are we going to assign the maximum value in a heap? It is going to be based on the maximum gain a particular class can get if one student is assigned in that class. Now let me try to solve the problem and then you will understand this. First of all, let me define a heap. So the heap is a list here. Next, what we can do is we can run a loop in our current value of classes. We can say for score comma total in classes. I want to append some data in the heap. So heap dot append. I want to append 3 different data in the heap. The first data based on which the data will be structured in the heap, that's the first key. So that will be the gain. What's the maximum possible gain for the current score and current total? Score is the total number of students who can pass. Total is the total number of students. So for the current value of score and total, what's the maximum possible gain? We are going to calculate the value of gain, but let us say we have the value, then that is the first value here, and we are going to actually assign the negative of it because we want to use the maximum heap. By default, the heap implementation in Python is min heap. So if we make it negative, this will behave like a max heap. And the second value we are going to push is the score, and then we are going to push the total. For the current score and total, if you add one more students, then this is the maximum possible gain. Let's create a function which is actually going to calculate the gain. So let us say def g. This is going to calculate the gain based on a score and total. And the formula for gain is going to be very simple. We can say if one student is added to the current score and current total, then the ratio will be score plus 1 divided by total plus 1, right? And now to calculate the gain, we can calculate the previous ratio, the previous passing ratio. So this can be score divided by total. We can just return this particular value. So this is the gain we are about to get if this is our current number of students who will pass the exam, and these are the total number of students, and we add one more student to the class. Now we are going to calculate the gain using the function g. So we can say this gain will actually be equal to, we can call the function g with the current score and total. Now we append this in our heap. This heap is a list. Now we can heapify our data, the heap data, so that we can actually get the next class in which we can add one more student to have the maximum gain. So what we can do is, after heapifying our data, we can just run a loop while extra students. So now we can pop out the first data which can give me the maximum score. So let's say gain comma score comma total is equal to heap pop from the heap. This heap is nothing but our own data, the list we created, and we added our data. After this we heapified our data. So now we are going to add one student in this particular class which has total number of students as total and the total number of passing students as score. So we can say score is equal to score plus 1 and total is equal to total plus 1. Now again we are going to update our gain value, because see, the thing is, this gain which we are storing is not the ratio, it's how much gain we are going to get if we add one more student in the current class. So now this is the total number of students in the class and these are the total number of passing students in the class. We could simply say that heap push. Let me push some data in the heap. First of all, let's calculate the new gain. So the new gain is going to be g with score and total, and now we are going to push the data in the heap. So we can say heap push. In this heap, push the data, and this is the data we are about to push. The tuple which has the first value as negative of gain, so that this heap behaves as a max heap, and the current score and total. And now we can say extra students minus equal to 1. So this loop is going to run for each of the students, and after we are out of the loop, our heap will have the updated value of the classes. The classes we have passing students compared to the total number of students. So the heap is going to store the updated data. And now we could simply say that result is equal to 0. Run a loop in the heap. So we can say for gain comma score comma total in heap, we could simply say that result is equal to result plus score divided by total, and return the result divided by length of heap, because we have to find the maximum average passing ratio. So to find the average, we are going to divide our total passing ratio with the total number of classes. Now you can submit this, and I think this is going to pass all the test cases, and this is a very efficient solution as well. You can see the runtime is pretty good, the memory used is fine as well. So we have solved this particular problem in a very efficient way. You can find the complete code of this particular problem in the pinned comment of this video. And guys, I think that's it for this video. If this video has helped you to understand the problem and the solution approach step by step, then make sure that you hit that like button. And if you have not subscribed to my channel as of now, then make sure that you subscribe to the channel as well. And I will see you guys in the next video. I want to see you guys in the next video. Thank you for watching this one.